In this section, we're going to begin looking at word problems, but we're not actually going to do them. We're just going to start the initial idea. We're going to provide you with a sentence, and you have to convert that sentence to an equation. Let me show you how this is handled. What we're going to have, I'm not going to, this is not comprehensive. I'm going to write some of these words up here and their meanings. Some of them are easy, like let's start with the word sum. Obviously, that means addition. Most of these you'll actually know, but just in case you don't. Difference. Subtraction. Increased by is addition. Decreased by, subtraction. What are some other words that we know? Product. Well, that's multiplication. That one's easy too. Quotient. That is division. And then finally the word is. That's equals. Like I said, this isn't comprehensive. More words will be introduced as I do these examples, but I just wanted you to see some of the ideas of what we're talking about. Your book inevitably probably has a bigger list than this, but I think you'll get more from it by looking at some of these examples than just reading about it. So let's start with an example, and I'll show you what I'm talking about. We'll start with 12 more than a number is 31. Now with these, you're asked not only to write this down as an equation, but to solve the equation as well. And these equations are never that hard to do. What I would do in every single one of these things is find the word, the verb. Most often it's going to be the word is or some form of is, and you have to recognize that. So in this, I can see that the word is clearly listed in the sentence. So that's where I'm going to position my equal sign. Now whatever's to the left of the equal sign will be to the left of the word is in the sentence. Whatever's to the right of the equal sign will be to the right of the right of the word is. So any numbers, you can bring them straight down. And most of the time, you can actually transcribe the sentence directly underneath of it if you write it out. So let's take a look at this part. 12 is easy. The word more than, that part right there, is addition. And then whenever they say a number, that's some unknown number, we can call it x. So there's your equation right there. 12 plus x equals 31. There's the equation, and then you're asked to solve it. And this is an easy equation to solve. Subtract 12 from each side, and I'll get x is equal to 19. So that's the gist of this section. All these examples will be exactly like this in structure. The word is not always directly there, nor can you always write directly underneath of all the words into an equation. I'll show you. I know we'll come up with an example because this next one will be exactly what I mean. This one gets students all the time, and it looks like this. 14 less than a number is 19. So here we got 14 less than a number is 19. Once again, there's the word is, and 19 is the only word on the other side of is, so that's easy enough. By the way, this is a sentence because the word is a verb. Now the other side's a little bit different. You would like to go 14 less than a number. All right, let's completely solve this, and then I'm going to X it out, so you might not want to write any of this down. Let's suppose that was what it was asking. How would you solve an equation like this? Well, you would start by subtracting 14, and I would get negative x is equal to 5. That's not solved yet. What I need to do is divide by negative 1 so that I can truly get x by itself, and I'll get x is negative 5. Now ask yourself, is negative 5 14 less, oops, I forgot the word less, than 19? Is it true that negative 5 is 14 less than 19? It's not true. In fact, negative 5 is 24 less than 19. So it's not correct. What was wrong? What was wrong was that we put this and this in the wrong spots. Those completely ruined it. The problem with trying to transcribe the sentence directly underneath like this failed. So you have to have some reading comprehension to do these problems. They don't work out always exactly. So here's what I'm going to do. I'm going to take my pen and I'm going to choose a big fat red marker and X this out. That was completely wrong in how to do it. Now I'd like to redo it, but correctly. So let me rewrite the example down. We have a 14 less than a number is 19. So let's take a look once again. I wrote out the word 19 before, but that's okay. I'll put equals 19. Now 14 less than a number. The way this should look on the left side is this. X minus 14. 14 less than, that means take away 14 from. That's what that means. 14 less than means 14 take away 14 from. So realistically, this sentence says take 14 away from a number, and that's equal to 19. The left side says it. Take 14 away equals 19. So there's my equation. Now let's solve it. Let me move it down here so it looks more reasonable to me. Let's go ahead and add 14 to both sides. And then we have x equals 33. Now, 14 less than 33 happens to be 19. So this is correct, and our sentence is correct. So you'll require two parts to this. I think I said, up here I made a mistake. I didn't mean it this way. Is 19 14 less than negative 5? No, 14 less than negative 5 is equal to negative 19. So if you do this wrong, get it backwards, you will get the negative of the answer. So you've got to be careful here. Make that's a special case, I think, but it always gets students, and I always seem to put it on exams. So be prepared for something like that. Let's take a look at another example. Similar, but a little bit different. 11 more than twice a number is 5. Once again, locate the is if there is one. And there it is. I'll put my equals underneath it there. The 5 is very simple. 11 more than twice a number. Now this one works directly. Even though it's the same structure as the previous sentence, the fact is addition is commutative. Subtraction is not. That's why this will work with addition but not subtraction. So with these, when it's more than, I can do 11. The more than is a plus. And then twice a number, I'll use 2x. So there's my equation. 11 more than twice a number is 5. To solve this, subtract 11 from both sides. You get 2x equals negative 6. Divide by 2, and we get x equals negative 3. So there's my sentence, or there's my equation. There's the solution. All the problems you'll be expected to do are like this. Next, we have 13 subtracted from 3 times, oops, not the, 3 times a number is negative 1. So this one, you probably won't make a mistake here because it says 13 subtracted from. So you know that this is going to be minus 13. We have the equals negative 1. That's easy enough. 13 subtracted from 3 times a number. Well, 3 times a number, there's 3x. There's 3 times a number. Subtracted from should give it away. We have a minus, then 13. So 3x minus 13 is equal to negative 1. Well, let's go ahead and solve it. So I have 3x minus 13 equals negative 1. First thing I'll do is add 13 to both sides of the equation and get 3x is equal to 12. To finish this off, I'll divide by 3 to get x equals 4. So I've got my equation and I've got the solution. All that's going to happen then is these become more complicated. I'll do a few more examples here. Overall, this will be a short video because this is the last subject before your first exam. Let's see what this next one says. We have 6 times a number is the same as 5 more than 7 times the number. I wrote small so I could fit the whole thing in there. So once again, I'm going to look for the word is. There it is, right there. Put my equals underneath of it. Let's see, on the left side, 6 times a number, that's easy. This part right here, 6 times a number, will simply be 6x. Now, on the right side, remember, this whole thing is the same as functions as the word is. So I'm going to put an equals underneath it, more centered. The other side actually works out well also. We can write it directly as they have in there. 5 more than 7 times a number. So that'd be 5 plus 7x. So let me go ahead and write the equation again so I could work it. Now on these, the best idea is to try to get the letters to one side first. So I'm going to subtract 7x from each side of the equation. That leaves a 5 on the right-hand side, but on the left I have negative 1x, or just negative x. I will divide by -1 on both sides and get x equals -5. So there's my equation, and there's my solution. Next we have the sum of 11 and triple a number is the same as 5 less than 5 times the number. So this one was too far for me to keep it on one line, but lucky enough, the is the same as is right here. Underneath that, I will put my equal sign. On the left, I have the sum of, that means addition, of course. What are the two things that I'm adding? It says the sum of 11 and triple a number. So 11 is easy, but triple a number is 3x, and I'll put my sum between them. So the sum of 11 and 3x, there we have that. The other side is 5 less than 5 times a number. Remember, this 5 less than means subtract 5. So the right-hand side will be 5 times a number minus 5. And so let me write my equation out. And let me go ahead and solve. Once again, the first object is to get the x on one side, and it seems to me a little bit more advantageous to get it on the right side because I'll avoid a negative in front of the x. And what will I have? I will have an 11 on the left, and on the right, I'll have 2x minus 5. Next, I will add 5 to both sides of the equation. And what do we have? We have 16 equals 2x. And I'm ready to finish it off now by dividing by 2. So x is equal to 8. So there's my equation. And there's the solution, or the answer at least.